Marge has 9 candies. Marge has 9 candies. She has 9 candies. Where n is an integer such that n satisfies this inequality here, that is n is between 20 and 50. So now you observe that there is no equality sign here, so that implies that 20 and 50, they are not inclusive. Now if Marge divides the candies equally among 5 children, she would have 2 candies remaining. Now this is the first statement here. The first statement says if Marge divides the candies equally among 5 children, she would have 2 candies remaining. That's the first one. Now the second statement says if she divides the candies among 6 children, she would have 1 candy remaining. That is the second statement, so I'm going to call that 2. So the last one says how many candies will remain if she divides the candies among 7 children. So again, questions like this, there is no single route in trying to solve this. There are different ways by which you can go about solving this. But then the thing is, of all the ways or all the techniques you could prefer in trying to find a solution to this, you need the one that is going to give you the solution the quickest, the one that will give you the solution faster. So from the first statement, let me just call this. So now what we have here is we are told that n lies between 20 and 50. So that is, you have 20 less than n less than 50. So to interpret this, it's like saying n lies between 20 and 50, and then we are told that n is an integer. That is an integer. So we said in the last video or last videos we've done so far that an integer is just a mathematical name for whole numbers. So the set of all whole numbers between 20 and 50, excluding 20 and 50. Why? Because there is no equality sign here. So that is, you have 21, 22, 23, 23, 24, 25, 26, 27, and then we could just keep on ranting like that until we stop at 49. So these are the set of all numbers that satisfy this inequality here. So from that to that. So now that is what we have in the first statement here. Since we do not know what n is, so that means n must be either of them, either 21, 22, 23 or 49. So I'm done with the first statement. Now let me now go back to the first one here. What this one says, it says if Marge divides the candies equally among 5 children, she would have 2 candies remaining. Now what that statement says is that of all these numbers, which of them, such that when I divide them by 5, I'm going to have 2 as my remainder. That's what it means. It says if Marge divides the candies equally among 5 children. If you divide 4 equally among two children, what you would have is, as if you have 4, if you divide them equally among 2 children, what you would have is 0. But when you divide 4 equally among 3 children, you're going to have a remainder of 1. So you can see what the statement just says is that of all the numbers you have here, which of them, such that when you divide them by 5, you're going to have a remainder of 2. So now you begin to look at them. Looking at 21, when you divide 21 by 5, you would have a remainder of 1. When you divide 22 by 5, you have a remainder of 2. So this falls in the group. So you have 22, so this passes. If you go to 23, it doesn't pass. 23 divided by 5, you have a remainder of 3. 24 divided by 5, you have a remainder of 4. 25 divided by 5, you have a remainder of 0. 26 divided by 5, you have a remainder of 1. 27 divided by 5, you have a remainder of 2. So that also passes. So you have 27. And then you do not have much time. So when what you observe here is like the second number here is 27, and it was obtained by adding 5 to this. So it simply implies that the subsequent ones you have to be adding 5 to them. So 27 plus 5, this is going to give you 32, plus 5 you have 37, plus 5 you have 42, and then plus 5 you have 49. You can check them. 32 divided by 5, you're going to have a remainder of 2. 37 divided by 5, you have a remainder of 2. The same thing for this. 49 divided by 5, you also have a remainder of 2. So now we have all these first numbers. So we have reduced them now. So it implies that the remaining ones can't satisfy the first condition. Now, I go to the next statement. It says if she divides the candies among 6 children, she would have 1 candy remaining. It says of the numbers we have here, that is for the second statement now. So the second statement says of these numbers that we have here, which of them is such that when you divide them by 6, you would have a remainder of 1. You have a remainder of 1. Now when you look at this, 22 divided by 6, you're going to have, this is going to be 6 in 22 is 3, remainder 4. So the remainder here is 4. It doesn't pass. When you divide 27 by 6, it's going to be 6 times 4 times 4 is 24. So you have a remainder of 3. It does not pass. If you divide this by 6, you have, this is 30, that's going to be 2. You have a remainder of 2. If you divide 37 by 6, this is going to be 36. You have a remainder of 1. So this passes. Then 42 by 6, you have a remainder of 0. So 49 by 6, that's 42, 48, 6 times, what's the name again? Oh, sorry, the number we chose earlier shouldn't have been this. This should have been 47. Sorry, this number here should be 47, right? Oh, I'm very, very sorry for this. It should be 47. The reason why I said this should be 47 is, you know, we chose all the numbers 22, 27 up to 42. So when we add 5 to 42, so this should be 47. So sorry for that, it should be 47. So when you divide 47 by 6, 6 in 47, that is 6 times this. So you should have a remainder of 5. So what we need is, we need just one of them such that you only have a remainder of 1, and you would observe that it's only 37 that passed the number. So that implies that n must be equal to 37. So now I have my n to be 37. Now what the last statement says is how many candies would remain if she divides the candies among 7 children. So what that means is that what is going to be your answer when you divide n, that is when you divide 37 by 7. So when you divide 37 by 7, so 37 divided by 7, this is going to be 7 times 5, 35. You're going to have 35. That's going to be a remainder of you have a remainder of 2. So your remainder should be 2, and then that completes the problem. So the solution of this problem is just 2. So what you'd observe here is many of the things they just did here is they just gave a kind of nicer way of saying some things, but to solve all these problems you need to give a mathematical description of all that is going on here, and then that makes the whole thing very easy for you. I do hope you understand this. Thanks for watching.